Hello everyone, so today I will be doing this 2023 Specialist Maths Exam 2 from VCAA, and I'm going to do extended response in this video, so let us get started. So, viewed from above, a seen walking track from point O to point D is shown below. Its shape is given by this following function. The minimum turning point occurs at point A, and point B is the inflection point, and the curves meet at point 1 and 0, which is point C, and the distances are measured in kilometers. Okay, so our first question. Show that A equals to minus 1. So we know that f of 1 equals to 0, so minus 1, 1 plus A whole squared equals to 0. So that means 1 plus A equals to 0, so A equals to minus 1. We can do the same with the other function to find B, so e to the power 1 minus 1 minus 1 plus b equals to 0, so that would be 1 minus 1 plus b equals to 0, so b equals to 0. There you go. Verify that two vectors move smoothly at point C, meaning that the gradient of both of these have to be the same at x equals to 1. So let us first individually define this in CAS. So define h of x equals to minus x times x minus 1 to the power of 2, and define g of x, which is equal to e to the power of x minus 1 minus x. B is 0, so we do not have to worry about that. Press enter, and there you go. So now let us find the derivative function as well. So I'm just going to define them. So dh of x equals to menu for 1 x h of x, and define dg of x equals to menu for 1. Again, we'll differentiate g over here, and there you go. So now let us find dh of 1, because that's where the curves have to be smooth. Yep, and let's find dg, so derivative of g at 1, 0. So as you can see, both of the gradients are equal. Okay, so we can say in our answer that let h of x be negative x, x minus 1 whole squared. Let g of x be e to the power of x minus 1 minus x. H at 1, derivative of h at 1 is going to be equal to 0. Derivative of g at 1 is also going to be 0. So since that is equals to that is equals to that, they join smooth. They smoothly join at C. C. Done. Find the coordinates of point A. So point A is the minimum point. Okay, so minimum point at the h of x graph. So we can set dh of x equals to 0. So solve dh of x equals to 0, x. We'll get our... Okay, so this has to be... Hold on, let me just use fmin function to avoid any confusion. So hx, x, what's our domain? I think it's 0 to 1. Inclusive, okay, 0 to 1. There you go. So this is our minimum point, and now we can substitute that back in, giving us negative 4 on 27. So it would be 1 on 3 and negative 4 on 27. And B is the point of inflection. Okay, so we have to differentiate dh of x, so menu for 1, dh of x, and then solve that equals to 0, x. And now let us substitute that back in to our h of x function. There we go. So that is our inflection point. So it is going to be 2 on 3 and minus 2 on 27. Done. Return track from point D to point O follows an elliptical path given by these parametric equations over here. We have to find the Cartesian equation of the elliptical path. Okay, so x minus 2 on 2 equals to cosine of t, and y on e minus 2 equals to sine of t. So we can say that x minus 2 on 2 whole squared plus y on e minus 2 whole squared equals to 1, right? So that's our Cartesian equation. So that's done. Sketch the elliptical path of from D to O on the diagram on page 10. So right here we'll have to sketch like that. However, it's going from D to O, so the arrow will be the other way around. Okay, so that is done. Write down a definite integral in terms of t that gives the length of the elliptical path from D to 0. So integral from pi on 2 to pi, and arc length formula now. So dx dt which is going to be minus 2 sine of t whole squared plus e minus 2 cosine of t whole squared and dt, and hence evaluate that. Okay, so to three decimal places and in kilometers, so we just have to find this integral out. So 4 3 pi on 2 and pi, and that is going to be for square root of minus 2 times sine of x. I'm just going to use x squared plus e minus 2, the whole thing again, times cosine of x to the power of 2 dx. Press Control Enter. Oh, maybe if I tried in radians. I just realized. Okay. I think I'll just take the radians one. I just realized when I press enter, I just realized that it's in degrees. Okay, I'll just take the radian one, I think. So 2.255 kilometer will be our answer. Okay, complex numbers. So let w equals to cis 2 pi on 7. Verify that w is a root of this over here. Okay, so z equals to 1 to the power 1 on 7 cosine of 2 pi k plus I sine of 2 pi k, where k is a positive integer. So that means that z equals to cosine of 2 pi k on 7 plus I sine 2 pi k on 7. When k equals to 1, we have cosine of 2 pi on 7 plus I sine 2 pi on 7, giving us cis 2 pi on 7. So that means we verified that. So that is all good. So list the other roots of z to the power of 7 minus 1 equals to 0. Okay, I'll just do that using CAS. So C solve, and z to the power of 7 minus 1 equals to 0, comma z. Okay. Maybe I'll try do it in degrees and see if I get something a bit more nicer than this. Okay, so I assume this is the angle. So if I were to convert this, and this is the degrees of course, so if I were to convert this into radian, we'll get negative 6.7. Okay, so one of the roots will be, so all of the roots will just be 6 pi on 7, negative 6 pi on 7, and then we have, okay, after that we have, okay, so cis negative 2 pi on 7, and then cis 2 pi on 7. Since that is already given, I'm not going to write that, and they just want the other root, not that, so we skip that one for now. And the other one is going to be cis minus 4 pi on 7 and cis 4 pi on 7, and the last one is just cis 0, which is going to be 1, but since they want it in polar form, I'm going to write it like that. Okay, so on the Argand diagram below, plot and label the points that represent all the roots of this. So we already have all the roots over here, and this is 1, 2, 3, 4, 5, 6, 7. Okay, so they have given us a good Argand diagram plane as well. So our first one is cis 0, which is here, then cis 2 pi on 7. This will be cis 0. Then it will be cis 4 pi on 7, cis 6 pi on 7, and then same here, so cis negative 6 pi on 7, cis negative 4 pi on 7, and lastly cis negative 2 pi on 7. Okay, so we have labeled everything, we have plotted them, so let's us move on. On the Argand diagram below, sketch the ray that originates at the real root of this and passes through the point represented by cis 2 pi on 7. So our only real root we had was this over here at 1. And cis 2 pi on 7 is here, so we can just draw a ray like this. Okay, that's done. Do we have to do anything else? Just 1 mark, so not really. I'll just label my starting point in case. Okay, and find the equation of this ray in the form of this where, okay, and theta is measured in radians in terms of pi. Okay, so this is going to be our theta over here, and this over here, I believe this angle is going to be 2 pi on 7, so this is going to be 2 pi on 7. How do we calculate theta? Oh, hold on, wait. This. Okay, I think this is an isosceles triangle, so that means this side and this side are both equal, meaning that this angle alpha and this angle alpha will be equal. So by using that, we can calculate it now. So 2 alpha plus 2 pi on 7 equals to pi. So our alpha is going to be, let's just calculate on CAS. Solve 2 times x plus 2 pi on 7 equals to pi. So x, or alpha, is going to be 5 pi on 14. So now, using that, we can just calculate theta, which is going to be pi minus 5 pi on 14, which is going to be 9 pi on 14. So our theta is going to be 9 pi on 14, and hence our equation is going to be argument of z minus 1, that's the initial point, equals to 9 pi on 14. Well, not 4, but 14. Okay. I think that's gonna be it for this question. I'm just gonna erase everything else over here because you're just meant to draw the ray and nothing else, so that all can go. Okay, and now, oh, even this theta. Okay, cool. Moving on. So verify that the equation, this can be expressed in the form of okay, maybe I can just expand. So it's that plus that plus that plus that plus that plus that plus that. And now minus 1 times the whole thing, so minus this. Yup. Okay, so all of this would just simply cancel out, leaving us with z to the power 7 minus 1. Express cis 2 pi on 7 plus cis 12 pi on 7 in the form of a cosine b pi. Okay, so I guess we can expand them first. So cosine of 2 pi on 7 plus I sine 2 pi on 7. Now cis 12 pi on 7, that is kind of like out of the argument domain. So let's see where that exactly is. So this is 0, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi. So this is the 12 pi mark over here. So that means 12 pi on 7 is equals to cis negative 2 pi on 7. And in fourth quadrant, cosine is going to be positive and sine is going to be negative. So we can say, hold on, let me erase this first. Okay, there we go. So we can say that this is going to be cosine of 2 pi on 7 still, and this is going to be minus I sine of 2 pi on 7 because sine is negative in fourth quadrant and cosine is positive. So that would cancel out, leaving us with 2 cosine of 2 pi on 7, and therefore our A is going to be 2 and B is going to be 2 on 7. Now we don't need this, but I'd still write it anyways just to be very safe. But yeah. Given that W equals to cis 2 pi on 7 satisfies that, use De Moivre's theorem to show that that is equals to that. Okay. Actually, hold on. I think I know it. So like we did for here, we had 12 pi on 7 equate to negative 2 pi on 7, where sine component just cancel out. The reason being that sine is positive for all of this over here, and it is negative for all of this part over here. So that means that if I were to add these two up, so if I were to add this and this up, I'll get 2 cosine of 2 pi on 7. If I were to add this and this up, I'll probably get 2 cosine of 4 pi on 7, and adding this and this up will give me 2 cosine of 6 pi on 7. And then of course we have that one root, so plus 1 equals to 0. So basically, okay, I think I have the idea. So basically, all of these roots over here, like z to the power of 6, 5, 4, 3, 2, 1, and plus 1, is like, sorry, so all of these roots over here, so 6, 5, z to the power of 6, z to the power of 5, so on and so forth, are going to be these roots over here with plus 1 at the end. Now, let's say our z6, let's say this is our z6 and this is our z3, meaning that this and this would be equal. Okay, so using that symmetry, we can say that, hold on, okay, my iPad's been a bit weird, but anyway, so we can say that 2 times cosine of 2 pi on 7 plus 2 times cosine of 4 pi on 7 plus 2 times cosine of 6 pi on 7 plus 1 equals to 0. Now that plus 1 comes from here, okay? Now, so if I were to take 2 out as a common factor, so 2 cosine of 2 pi on 7 plus cosine of 4 pi on 7 plus cosine of 6 pi on 7 plus half equals to 0, so which will give us cosine of 2 pi on 7 plus cosine of 4 pi on 7 plus cosine of 6 pi on 7 plus a half equals to 0. So finally we have cosine of 2 pi on 7 plus cosine of 4 pi on 7 plus cosine of 6 pi on 7 equals to negative a half, which is what they want us to prove. Okay, so there we go. That's how we do it. Okay, so question 3. The curve, this is given by, okay, where the domain is between 2 and 5, rotated about x-axis to form a solid volume of revolution. Route down and define an integral in terms of x to show the solid revolution. Okay, so v equals to 2 to 5, and then y squared, which is going to be x minus 1 dx. And hence find the volume of the solid of revolution. So you can just integrate. So pi times menu for 3, 2 to 5, x minus 1 dx. Yep, so 15 pi on 2. Express the curved surface area of the solid in the form of this, where a, b, capital A and b are all positive integers. So curved surface area, what is curved surface area? Hold on. So our graph looks like this. Okay, so it is rotated about the x-axis. Okay, so they are referring to surface area being formed when we have rotate this graph around x-axis. Okay, I see. So we can just use the formula for that. So let me just get the formula up real quick. So our surface area formula is going to be, okay, so I have it now, but I have to calculate dy dx first. Okay, well, just dy dx times 2y equals to 1, so dy dx equals to 1 on 2y. Okay, implicit differentiation for the win. Anyway, and now applying the formula, we will get 2 to 5, 2 pi y, and square root of 1 plus 1 on 2y whole squared, and dx. Okay, interesting. Actually, I cannot use this way because then it would not make mathematical sense. Like, notation would be wrong because I'm writing in terms of y, but I'm writing dx. So maybe I have to make y the subject first. So y equals to square root of x minus 1, positive or negative. However, y is greater than 0 because that's the domain. So we'll get y equals to square root of x minus 1 over here. And now we can just apply the formula, so 2 to 5, 2 pi times x minus 1, and then times the whole thing by 1 minus differentiation of this menu for 1 square root of x minus 1. So, okay, 1 on 2 root x minus 1 whole squared dx. Okay, that looks a bit better. Okay, so continuing, so 2 to 5 integral of x minus 1, and then let us simplify this, so 1 minus 1 on 4x minus 1 dx, which is going to be 2 and 5 that x minus 1, and then this will be 4x minus 1 minus 1 on 4x minus 1 dx. Actually, no, it's okay. I'll just take on the next step. So 2 pi x minus 1. We can write 4. So we can write this as it is, but the denominator we can say that 4x minus 1 is the same as, again, 2 root x minus 1 whole squared. So I'm just going to take that out as that. So now this and this cancel out. Okay, leaving us with 2 to 5 pi times 4x minus 5. Oh, hold on. Wait, this meant to be plus. Okay, plus, plus, plus. So this wouldn't be negative 5. This would be, what would this be? Minus 3. So which is equals to pi times 2 to 5 4x minus 3 dx. What to write dx? Okay, so there we go. A equals to 2 and B equals to 5. Capital A equals to 4 and B equals to 3. Okay. Hence or otherwise find the curved surface area of the solid correct to 3 decimal place. Okay, so now we just type this integral out and find it. So menu for 3, and it will be 2 to 5 square root of 4 times x minus 3. Control enter, and there you go. So this is going to be our surface area. So 30.8, 3 decimal places, 47. Okay, let's move on. Wait, hold on. I think I did my calculation in degrees. Yes. Let me just change that to radians and still do it again just to make sure nothing is... Okay, good. Just for the safe side. The total surface area of the solid consists of the curved surface area plus the areas of the two circular discs at the end. The efficiency ratio of body is defined as its total surface area divided by the enclosed volume. Right. Okay, so our graph, it looks like this. So we are talking about this two circular disc that is formed over here. We have to include the area of these two circles as well. Okay, so we have to first find this radius for both of the circles. So we know that our x is going to be equals to 2. So x is equals to 2, so y squared equals to 2 minus 1. So for the smaller circle here, our radius is going to be 1. And for the bigger circle, y squared equals to 5 minus 1. So y equals to 2. It's going to be 2. So we just have to find total surface area, which is going to be 30.847, yep, plus pi r squared, so r is just going to be 1, so it's just going to be pi, plus 4 pi, and that is going to give us, just chuck this on CAS again, 4 pi, 46.55, and our volume we had was 15 pi on 2. So our efficiency ratio is going to be 46.55 divided by 15 pi on 2, which is going to be that divided by 15 pi on 2, which is going to be 1.98, because it says 2 decimal places, so 1.98. Okay. Another solid of revolution is formed by rotating the curve given by this. It's the same curve about the x-axis, again same axis as well. And for this domain, 2 to k, where k is all real number, and k belongs to all real numbers, I mean, this solid has a volume of 24 pi. So we do find the efficiency ratio of this solid, giving answer into correct to 2 decimal places. Okay, so first we have to find the value of k, and we can do that by using the fact that volume is going to be 24 pi. So v equals to pi times that, and the integral is going to be 2 to k, and then x minus 1 dx, which is going to be 24 pi. So let us solve for the value of k. So solve menu for 3. Of course, I have to multiply this by pi. So 2 to k, and x minus 1 dx equals to 24 pi x, comma k. So k, which implies that k is going to be minus 6, or k is equals to 8. Now k cannot be minus 6 because of, look at the domain, just cannot be minus 6. So k has to be greater than 2, so k equals to 8. And now we can use the same integral that we found over here to calculate the surface area of the curved surface. So curved surface area equals to 2 to 8 of pi times this integral 4x minus 3 dx, because the curve is the same. So we can do that. I'm just going to copy this integral down, change it to 8. So 75.92. And now we have to find the circles as well. So again, our graph is going to look like this. So we are looking at these two circles over here. This one would be the same with the radius of 1. This one would change because our domain has changed. So now our maximum is 8. So y squared equals to 8 minus 1. So y equals to root 7. So it's going to be root 7. So what do they call that? Plus the circular disc. So area of discs is going to be pi r squared. So r is just 1, so pi plus pi r squared, so 7 pi, which is going to be 8 pi. So 7.952. Ooh, I had to write total surface area equals to 75.92 plus 8 pi, which is going to be plus 8 pi, 101.05. And our efficiency ratio would be 101.05 divided by 24 pi, which is gonna be that divided by 24 pi, so 1.34. 1.34. Yep, okay, that makes enough sense to me. Yep, okay, moving on. A farmer releases 200 fish into a pond that originally contained no fish. The fish population grows according to the logistic model, where t is the time in years after the release of 200 fish. The above logistic differential equation can be expressed as... Okay, so they have just basically reciprocated this over here, and then did the expansion of that. So we can do the same. 1 divided by p times 1 minus p over 1000, which is gonna be that, and we can just do expansion of this. So 1 on p minus 10,000. So we know that a is going to be 1 and b, okay, so it doesn't quite match this form. So okay, what happens if I just put, okay, maybe I can just do b divided by 1 minus p over 1000, and I get this. And okay, so this and this are very similar, as you can see. So what I'm going to do is I might just denote this as A. P minus 1000 is going to be our A. It's going to be our A. So solve for B. So B is going to be 1 minus 1000. Okay, there you go. B equals to negative 1 on 1000. Right, okay. One form of solution for P is going to be this, where D is a real constant. Find the value of D. So we can just use the information that when T equals to 0, the population will be 200 because he just released that, and yeah, so we can say that P of 0 is going to be 200. So we have to first define, so define P of T equals to 1000 divided by 1 plus D times E, E to the power of minus T. Okay, so P of 0, solve that, equals to 200 and comma D. Okay, so our D is going to be 4. So that implies that D is equals to 4. The farmer releases a batch of N fish into the second pond, which is originally contained no fish again. The population of that pond can be modeled by this, where T is the time in years after N fish are released. Find the value of N. So we have to basically find Q of 0 equals to N, which is equals to. Okay, so define Q of T, which is equals to 1000 divided by 1 plus 9 times, not bracket, 9 times E to the power of negative 1.1 times T. And so Q of 0 is going to be 100 fishes. Find the value of Q when T equals to 6 to the nearest integer. Okay. 987, so that is 0.9, so 988. 988 fish. Okay. Given that dq, so dq dt equals to this, express that in forms of q. So we just have to differentiate this entire chunk one more time. So, okay, for 1 x and then 11 on 10 times q, or to use maybe some other variable menu. Okay, maybe I can just delete q now. Okay, well, I shouldn't have done that, but it's okay. If in case I needed that later on, I shouldn't have deleted q, but that's okay. You can just define it again if I do need that function. So 1 minus q over 1000. Okay, have I defined it correctly? Yep, I have. Okay. So our d to q on dt squared equals to 11 on 10 minus 11q on not small q, big Q on 5000. Hence, or otherwise, find the size of the fish population in pond 2 and the value of t when the rate of growth of population is at maximum. Give your answer for t correct to the nearest year. Okay, so we can just set this equals to 0, so dq on dt equals to 0 to find the value of q. So solve that equals to 0, q. So we get q equals to 500, and now we have to put the 500 back into this equation. Okay, so I shouldn't have undefined this equation, but that's okay. I'll just quickly define it again. So define q of t equals to 1000 on 1 plus 9 times e to the power of negative 1.1 times t. Okay, so solve 500 equals to qt, comma t, and t is going to be 1.997. So give your answer to nearest here. So 500 equals to, I'm just gonna write the function down, so q, so okay, my iPad is not cooperating right now, I don't know. Okay, there we go. 1000 on 1 plus 9e to the power of negative 1.1 t. So therefore t equals to 2 years. Okay, cool. Oh, again. Okay, what do we have to sketch? Ah, my iPad is not cooperating. Okay, sketch the graph of q versus t on the set of axes below. Label any axis, intercept, and any asymptote with their equations. Okay, so what we can do is we can use limits to find the horizontal asymptote. Because this is a logistic function, there will be q equals to 0 as one of the asymptote and q equals to 1000 as the other one, I think, if I'm not mistaken, but I'm just gonna check with the limit as well. So x approaches to infinity of q and x, I'll just say x. Okay, so 1000. Okay, so one of the asymptote is going to be q equals to 1000, and the other one is going to be q equals to 0. So we know that the initial population is like 100, if I remember correctly. I can just go quickly check. Yep, 100 fishes. Alright. Oh. There we go. And we know that our inflection point is at 2 and 500, roughly around there. So it's gonna be something like this. Okay, no. Something like that. Now we have to label everything. So this is going to be 0 and 200. And oh no, not 200, 100. Oops. Oh, and the reason why this is q and not y is because here it's q and not y. As simple as that. Okay, moving on. So a farmer wishes to take 5.5% of fish from pond 2 each year. Okay, the modified logistic differential equation would be this. And q in pond after t years. Okay, so find the maximum number of fish that could be supported in pond 2 in this situation. Maximum number of fish that could be supported in pond 2 in this situation. Yeah, so we can just say that dq dt equals to 0 for this, and then solve for the value of q, and that will give us our answer. So it would be the exact same thing that we just typed here, like this. Okay, I have to, maybe I'll just say a and not q. I don't want to delete q again. And then minus 0.55 0.055 times a. Solve that equals to 0, comma a equals to 0, a equals to 950, so our q is going to be 950 fishes. There we go. Ooh, okay, so vectors now. The points with coordinates this, and that lie all in a plane. Okay? Find the vectors AB and AC, and hence show that the area of the triangle ABC is 1.5 square units. So AB is going to be B minus A, final minus initial, so I plus 2J plus 3K minus I plus J plus 2K. So that is going to equals to J plus K. And AC is going to be equals to C minus A, so 3I plus 2J plus 4K minus I plus J plus 2K, which is going to equals to 2I plus J plus 2K. And I think the area of the triangle would just be half times cross product of these two vectors and the magnitude of that, of course. So let us find the cross product of these two vectors and of course their magnitude. So cross product of 0, 1, 1, which is AB, and the second vector will be 2, 1, 2, which is going to be AC. And let's find the magnitude of that. So 3, so that will be 2 times 3, which is indeed 1.5 square units. Okay, find the shortest distance from point B to the line segment AC. So I have a formula for us to use, so that will be distance equals to magnitude of cross product of vector AB and the AC. So this vector over here. So 2i, so I can just write AC on magnitude of AC. I don't know if you guys use this, but I personally just use that. So anyway, so we can calculate the distance based on that. So our AB vector and AC vector, we already have the cross product, which is going to be 2, and our AC vector, so we already have the magnitude of AB cross AC, which is going to be 3 as calculated previously. And let us calculate the magnitude of AC. So norm of this over here is also going to be 3. So our distance should be 1. So distance equals to 1. Okay. A second plane has Cartesian equation of this. What acute angle does the line given by this intersect? Does the line given by this intersect the plane? So we have to find the acute angle. Okay. So what I'm gonna do is we can just use cosine inverse of the dot product. So 2i minus 2j minus k. That's for plane, and I minus 2j plus 2k. That's from here all over the magnitude of this, so 2i minus 2j minus k, and I minus 2j plus 2k. So you can use calculator to find this cosine inverse, just say arc cos. Wait, I have to change from radians to degrees first for this specific question. And then we have dot product of 2, minus 2, minus 1, and 1, minus 2, 2, and norm of 2, minus 2, minus 1, and times it by norm of 1, minus 2, 2, enter. Okay, so our angle is going to be 67.36. Now, this is not acute angle, so for that we just do 90 take away 67.36. So 90 take away that. So we'll get 22.63, which to nearest degree is like 23. Okay, moving on. So a line that passes through origin and is normal to the plane. The line intersect plane at point D. Write down an equation of the line. So our line is going to be 2i minus 2j minus k t, where t is all real numbers. So that is our line, because it only passes to origin, so there's no point adding the the coordinate, not the coordinate, but the intercept kind of a deal. So it doesn't matter. So our line is just going to be that. and find the shortest distance from the origin to the plane. Now I have a formula for this as well. So here the distance is going to be the modulus of minus 18 over here, minus 18 over here, and then magnitude of 2 squared plus 2 squared plus 1 squared, and all of these are just the coefficients of x, y, and z. So yep, and evaluating this on CAS, so that square root of 2 squared plus 2 squared plus 1 will give us 6. So our shortest distance is going to be 6. Okay, moving on, find the coordinates of point D. Right, so coordinates of point D. Okay, so we have our equation. So x is equals to 2t. I got that from here, from this line equation. X is going to be 2t, y is going to be minus 2t, and z is going to be minus t. So if I can scroll again, okay, y is going to be minus 2t and z is going to be minus t. Okay, if I can scroll back up again. Yep, and now we can just substitute that into the equation of plane, which is going to be 2x minus 2y minus z equals to minus 18, I believe. Yep, so we can just substitute x, y, and z in here. So we'll get 2 times 2t minus 2 times 2, negative 2t, and then minus t equals to minus 18. So 4 plus 4t plus 4t plus t equals to minus 18. So 9t equals to minus 18 and t equals to minus 2. So they intersect when t is at minus 2. And now we can just substitute this t back into this xyz coordinate to find the coordinate itself. So we'll get minus 4, 4 and 2. So that is going to be our point D. Okay, moving on. So we have our probability question. How many questions are there? Okay, this is the last one. Okay, good. A forest ranger wishes to investigate the mass adult male koalas in Victorian forest. A random sample of 20 koalas has sample mean of this. It is known that the mass of adult male koala is normally distributed with standard deviation of 1. Find a 95% confidence interval for the population mean. Give your answers to 2 decimal places. Okay, so menu 1 and stats. So our standard deviation is 1, sample mean is 11.39, our n is going to be 20, and we want 95%. So okay, so our confidence level would be 10.95 and 11.83. Okay, so again, my iPad is not scrolling. There we go. 60 such random samples are taken and their confidence interval are calculated. In how many of these confidence interval would actual mean mass of all adult male koalas be expected to lie? So 0.95 times 60 should be it. So 0.95 times 60, or not 96, 95, we have 57. Okay, and the ranger wants to decrease. The ranger wants to decrease the width of 95% confidence interval by 60% to get a better estimate of population mean. How many adult male koalas should be example to achieve this? Okay, so our current confidence interval will have what's our width of the current one? So if I were to do that, take away that, and that is our current width, and now I just want 40% of that, so times 0.4, because we want to decrease it by 60, so the only remaining would be 0.4. So this should be the width. And now if I were to solve using the confidence interval formula that our sample mean 11.39 minus, okay, I'm gonna say because bigger minus smaller, so 1.96 times standard deviation, which is going to be 1 divided by, we don't know the amount of koalas required as of now, so I'm just gonna say n, and then minus, again we have to have the same thing except for the minus sign, like so, and equals to that amount of width. And okay, so n is going to be 124.9, so which is going to be 125. Yeah, so I hope that made sense. So all I did was I first found the width of the confidence interval we found in part A, and then I reduced it by 60%, so I multiplied it by 0.4, and then I just used the confidence interval formula from the formula sheet and subtracted the endpoints and set it equals to this number over here, because that's the width that we are looking for and we don't know the n, so I just find n by using that. Okay, moving on. It is thought that the mean mass of adult male koalas is 12 kilograms. The ranger thinks that the true mean mass is less than this and decides to apply one-tailed statistical test. A random sample of 40 adult male koalas is taken and sample mean is found to be 11.6. Write down the null hypothesis of HO. Okay, so HO is going to be mu equals to 12 kilograms. Do we have to write? No, we don't have to write units here. Okay, and H1 is going to be less than 12 because 11.6. Okay, moving on. So the ranger decided to apply one-tailed test at 1% significance and assume that mass of male koala normally distributed in mean of 12 and standard deviation of 1. Find the p-value for the test correct to 4 decimal places. So our p-value would be normal CDF. You don't have to write this in the exam, but I'm writing it just over here. From minus infinity to 11 point, what was the true mean? Oh, 11.6. Mean is going to be 12 and standard deviation is going to be 1 on square root of 40, and that will be our p-value. So let us quickly do that. Menu 552, so lower bound is negative infinity, 11.6, 12, and 1 on square root of 40. Let's enter. So our p-value, I'm just going to erase this out. So our p-value is going to be 0.0057 to 4 decimal places. Draw a conclusion about the null hypothesis in part D from the p-value found above, giving a reason for your conclusion. So since p-value is less than statistical significance, we reject HO. Okay. What is the critical sample mean, the smallest mean for HO to not be rejected? In this test, give your answer in kilogram to 3 decimal places. So we're basically using inverse normal function over here. So it would be 553. Area is going to be 0, 1. That is going to be that, and 1 on square root of 40. So we'll get 11.632 kilograms. Okay, kilograms to the 3 decimal places. Suppose that the true mean mass of the adult male koala in the forest is 11.4 kilogram and the standard deviation is 1 kilogram. The level of significance of the test is 1%. What is the probability correct to 2 decimal places of the ranger making a type 2 error in the statistical test? Okay, so we can first find the z value of this. So we have z equals to, our x bar is going to be 11.632, which is the critical value that we found. Take away true mean, which is given over here, 11.4, divided by standard deviation, which is 1 on square root of 40. And we just have to find probability that z is greater than whatever we get over here, because type 2 error is, because type 2 error, let's say we have our 2 over here, the bell curves. So let's say our mean is over here. Then our type 2 error would be just this section over here, so it has to be greater than or not, and not less than. So let's do this on CAS now. So that's our Z value over here, and now we can just menu 552. I'm just gonna put 1 for now, and then we can adjust everything later. So instead of negative infinity, our lower bound is going to be that, our upper bound is going to be infinity, and so our answer is going to be 0.071. Okay. Oh, okay, wow. The frequency of the curves for sampling distribution associated with this and that are shown below. Label the critical sample on the mean diagram and shade the region that represents the type 2 error. So our critical mean was 11.632. So this is 1, 2, 3, 4, 5. So 0.1 interval. So 11.6 is here. So our mean was somewhere over here. So this will be our mean, so that was 11.632, and our type 2 error, as I already showed earlier on, would be this section over here. And I think that concludes everything. Okay, so that is it for the extended response. I will do multiple choice very soon. Thank you all for watching, and all the best for any future exams you have.